So we talked about how to evaluate types of functions, right? Now, and everything what we're talking about is x is approaching a specific value. For example, x is approaching 2, right? S is approaching 3, S is approaching, let's say, 5 of f of x. Now, in this video, what we are going to talk about is very simple. We are going to talk about evaluating limit, but here x is approaching infinity. And then as x is approaching infinity, we look at type of functions and how it's going to behave. So for example, we start with the polynomial function again. So when I want to find limit as x is approaching infinity, what am I going to get? So that is basically what we just need to look at. So I have a polynomial function here. Now, as I defined from the previous video, we said polynomial functions are something like this up to the constant term a naught. And we said with the polynomial function, we just need to do direct substitution, but this is infinity. So with this, we have two solutions for this. Now, anytime it is a polynomial function, the infinity dominate. So for example, if we are using this one, then this will be the same as limit x is approaching infinity of let me say a n x n. All the other term will just go away because it's infinity will just dominate all the other constant. And when I plug in infinity, this blow up and we get infinity. So it means that anytime x is approaching infinity of a polynomial function, I'm going to get what? Infinity. But let's add another one term to it. Let's assume that x is approaching negative infinity of p of x, which is going to give us limit x is approaching minus this and this. This gives us two answers, right? So one, it either gives us a polynomial function, like it either gives us positive infinity or negative infinity because of this. Now this gives us negative infinity if n is odd, like odd function, and when n is even function. So pay attention to that. So if n is, let's say, x squared, this becomes positive. When it is odd, let's say x cubed, x to the power 1, x to the power 5, this becomes negative infinity. So these are some of the things that we need to learn so far as polynomial function is concerned and x is approaching either positive or negative infinity. Good. Let's look at rational function. I love rational functions a lot because they always comes with rules. Now let's look at rational functions. So rational functions is, as we learned, like limit x is approaching infinity, then r of x, but we are going to denote this one as x is approaching infinity, and then we have f of x divided by gen of x. Don't forget, always rational function, the top is a polynomial function and the down two is a polynomial function. But now what can we do? We have three rules that is going to guide us through this, which is very simple. Let's learn them, which is going to help us to go through the procedures. So the first one is, as we said, always whenever you have a polynomial function, because s is approaching infinity, the highest degree dominate, right? So this is what we are going to do. First, we have three conditions. When the degree of the top, so when the degree of the numerator is greater than, so we are just doing them, is greater than, okay, let me just do it this way. Let me write it mathematically. So when the degree of f of x is greater than the degree of gen of x, then so when the top is greater than the down, then do you know what we are going to get? We are going to have something like let's say x to the power 3 divided by x to the power 2, because the top is greater than the down, right? So if this is going to give us a polynomial function, let's say x. So this is going to give us infinity. So it depends. Whenever you do it and you get a polynomial function, it comes back to one of this. Either you are going to get it positive or negative. So that is what you are going to get. Now 2 is when the degree of the numerator is the same as the degree of the denominator. So anytime you are dealing with x is approaching infinity, it's kind of you are dealing with horizontal asymptote kind of something. So when they are the same, then the limit, so I need to write here, let me write here, the limit is infinity. So that is what we need to like get here. So the limit is infinity. So here when they are the same, then the limit is the ratio, we will take example for you to understand, is the ratio of the coefficient of the leading, or of the coefficient of the highest degree. So we will take example, you will see what we are trying to say. So this is what I'm trying to say here. Good. So that is the second one. Let's look at the third one. The third one is when the degree of the numerator is less than the degree of the denominator, right? So the denominator is 10 of x. If that happens, then the limit is, if that happens, then the limit is 0. So that's what you need to pay attention to. Whenever the numerator is less than the denominator, the limit is equal to 0. So these are the three things that's going to guide us whenever we are dealing with a function which is a rational function and x is approaching infinity. We will take examples for you to, in the same video, for you to understand it better. But these are the three things that we need to remember. And remember, when we are dealing with horizontal asymptote, we saw that, yes, if this is true, then the horizontal asymptote is 0. And then if this is true, then the horizontal asymptote is the ratio of the coefficient of the highest degree. And then if this is true, then there is no horizontal asymptote, but we have what? Oblique asymptote. So remember that. Good. So let's take example and let's practice, right? And see what we are going to get. So this is a polynomial function, but x is approaching negative infinity. So let's see what we are going to get from here. This is going to give us limit x is approaching minus infinity 5x to the power 9. So since this is infinity, the highest degree dominates. So all this will just go away and it will be left with this. So since this is negative, then we just need to look at this, whether it is odd or even. So since this one is odd, then what are we going to get? Since it is odd, we need to have negative infinity. Good. So since this is 9, which is odd, this is going to give us negative infinity from here. So basically, that's what you're going to get from here. And let's look at this one. This is a rational function, and this will be equal to limit x is approaching infinity. So the highest degree will dominate. So the top has a highest degree, which is 2x to the power 3 divided by the down has a highest degree, which is 2x squared. So all the other terms will just go away because it's going with infinity. So when you have something like this, we can simplify this and we are going to have limit x is approaching infinity. Now 2 will cancel 2, This is x squared, and it will cancel this one, and it will be just left with x. And this is odd, and since this one is even positive, this one will just be equal to positive infinity. So you see that that's what we said. If the degree of the top is greater than the degree of the down, then we have infinity, which is right here, right? So, but this basically depends on if this is approaching positive infinity. But if it's approaching negative infinity, then this condition will also hold the same way. Good. Let's take another example. Let's take another example. Now let's assume this one too. So this is equal to limit x is approaching positive infinity. Let's pick the ones with the highest degree. So this is the highest degree. So we are going to have 7x to the power 4 divided by, which one is the highest degree? This one. So we just pick the ones with the highest degree, x to the power 4. So now the magic happens. X to the power 4 cancel x to the power 4. And we are going to have limit x is approaching infinity, 7 over 6. And we know that limit of a constant is the constant, because no matter the value of x, because this does not depend on x, we have this. And this one tells us that when the degrees are the same, we just need to use the coefficient, the ratio of the coefficient of the degree. So this is the ratio, which is 7 over 6. As we said from here, that if they are the same, if the degree are the same, is the ratio of the highest degree, coefficient of the highest degree. So the coefficient of the highest degree is 7 over 6. What is this? So whenever you are solving objectives, some of the terms you don't need to solve. You just look at it and then you just tick your answer. So for this, I don't need to go through this. I just need to look at this and say that this is 7 over 6. And then I just check the option if it is there. Same thing to this kind of thing. Unless maybe you are confused and you want to verify, and then just do it that way. So this is some of the way that you can do some of the things for you to finish your objective very fast, very, very fast. Good. Let's look at D. Now with D, we have this one to be limit x is approaching infinity, and then the highest degree here is x to the power 5, and then the highest degree here is x to the power 6. So this is the same as limit x is approaching infinity. We can cancel this and that. So I'm going to have 1 divided by 2x. And this is going to be 1 divided by infinity. And a small number divided by a big number is approximately 0. So this is going to be given as 0. So as we said, when the degree of the numerator is less than the denominator, we get the limit to be 0, as we've seen from here. So the degree of the numerator is less than the degree of the denominator. So this is going to give us 0. So these are some of the analysis that you can do to determine, okay, this is 0, this is that, and this is that. So I think these are everything that you need to know so far as x is approaching infinity. X is approaching infinity, the polynomial function, and then a rational function too as well. So I'll give you a trial question to do, and then you leave your final results in the comment section. So try this and try this, follow the same procedure, and put your final results in the comment section. So when you become good, if you have become good with the video that we did, you can see that you can even use your eyes to even just put your answer in the comment section. So see you in the next video.